Okay, we are starting our next foldable, which is on Unit 15 circles. And you can go ahead and make your foldable. Make sure there's 6 tabs to it. Okay, 5 tabs, but 6 parts. And go ahead and make sure you write your name on the front. So write these down today. We're going to start with standard equation of circles. Okay, we're going to have a couple slides here. Okay, not a lot of work, but a couple slides. So this is the standard equation of a circle, and just so you know, a circle is a set of all points that are equidistant, which means the same distance, from a fixed point on the circle, which they call HK, and we call that the center. Okay, so up here, HK represents the center, so I'm going to go and write that down. So HK is the center of the circle, and we know R is the radius. So if you know the center of the circle and you know the radius, you can write an equation. So a lot of these will be real easy to do. All right, so let's go ahead and look at a few examples. I got 3 examples up here. If you notice in the formula, the standard equation of a circle is x minus h squared and y minus k squared. So it's really the opposite of what's in the middle. So on this first one, okay, you're subtracting 7. Okay, from x, and you're adding 4 from y. So if you put the opposite of those in, you'd have the center. So the center on number 1 should be positive 7, negative 4. And the radius, we know the last number here is the radius squared. So to work backwards, the radius is the square root of that. So the radius is the square root of 36, okay, which is 6. So again, really easy. Okay, number 2 up here. Okay, since there's not a number next to the x that you're subtracting, you assume that that is 0. So your center on number 2, okay, is 0 for the x. Okay, and the opposite next to the y is 3, so 0, 3. And again, the radius is always the square root of the last number, and that one cannot be simplified, so you just leave it as the square root of 7. Okay, number 3. There's nothing that you are subtracting away from either one, so your center is the origin. Okay, origin, which is 0, 0. And your radius, again, is the square root of the last number. Okay, if you were to make a tree, you would see that that would simplify down to 2 radical 2. Okay, so again, pretty easy once you have an equation to refine the center and the radius of the circle. So let's go ahead and work backwards, and let's go ahead and write an equation when we're given the center and radius. Okay, and again, this is fairly easy too. So remember, you're going to put the opposite in. So at the beginning, okay, the first one, you're going to have something with x squared in it, something with y squared in it, and then equals a number. Okay, so the opposite of negative 3 is positive 3, so that will go in here. The opposite of positive 5 is negative 5, so that will go in here. And the radius squared at the end, okay, the radius is 4, so we put 4 squared at the end, which is 16. Okay, so that'd be the answer to the first one. Okay, the second one, okay, the center is the origin, so remember, you don't have to put minus 0. So if the center is the origin, that means it's 0, 0. I'm going to go ahead and write that in, 0, 0. So I can write that part like that. And then my radius squared, the square root of 3 squared is just 3. Okay, so that would be the answer to that one. Last one's a little bit harder. I can write part of it already because I know the center. So the first part of it will be x minus 2. I'm putting the opposite of the 2 first. And then the opposite of negative 3 would go next to the y. Okay, I need to figure out the radius. It says it passes through the point negative 3, 9. So what you're going to do is you're going to have to find the distance between the center and that point. Okay, between the center and that point. And if you remember the distance formula, okay, you can do that. So here's the distance formula if you don't remember. The distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so I'm just going to use that, find the distance between those 2 points. So if I do that, you have an x coordinate here and an x here, so you have negative 3 minus 2. That's your x coordinate subtracted, squared. And then your y-coordinate squared, if you go in the same order, is 9 minus negative 3. So the second y-coordinate minus the first one. Okay. And that should give us the distance between the 2 points, which is our radius. So this right here ends up becoming, if you type that in on your calculator exactly like I put it, that's 25. And if you type this one in on your calculator like I put it, you get 144. Okay, so when you add those together, you get 169, the square root of 169, which should be 13. So your radius is 13. Okay, that's the distance from the middle to any point on the outside is 13. So at the end of this equation, remember, you want the radius squared. 13 squared is 169. Okay, so that'd be your equation for that. So that's really the only one you have to do any work on. Okay, and here's the last question or foldable. It's going to ask us to write an equation of the circle shown in the graph. So again, as long as I know the center and I know the radius, I can write the equation. Okay, your center appears to be right here. And if you look at that coordinate, you're going over 2 and down 5. So 2, negative 5 is your center. Your radius is the distance from the middle to any other point. So I can look real easily. So that could be a radius right there. And that distance from negative 5 all the way up to negative 2, that has a distance of 3. So my equation of the circle would be x minus 2 squared plus, remember you're putting the opposite in, y plus 5 squared equals your radius squared, and your radius is 3, so 3 squared is 9. So that should be your answer. When you go to graph these in Math Excel, if they ask you to graph a circle, it's real easy. Okay, you plot the center first. Okay, you put a dot on the center, and then you just move the circle as far out as the radius is and click another dot, and your circle is drawn.